A pleasant day to each and everyone, especially to our instructor, Ma'am Halima A. Mantawil. Ma'am, I am Sahada B. Canapea, Bachelor of Secondary Education, major in Science 3. And today, I am discussing to you the Chapter 8, Metamorphic Rocks. When we say metamorphic rocks, it is the rocks that change and become different rocks. If we look in this illustration of the rock cycle, we can say that when a sedimentary rock is exposed to a heat or pressure, it turns into a new rock or what we call metamorphic rocks. The same thing with the igneous rocks. If they are buried on the ground and exposed to large heat and pressure, it turns into metamorphic rock. And even a metamorphic rocks, if it can buried in the ground and exposed to heat and pressure, it becomes new metamorphic rocks. So, metamorphic rocks are formed when existing rocks are changed by great amounts of heat or pressure. So, the word metamorphic comes from a Greek word, meta, which means to change, and morph, meaning form or shape. The parent rocks are called protoliths. That's why metamorphism can occur to any protoliths. And the extreme heat and pressure change the physical appearance and chemical makeup of the rocks, and it becomes metamorphic rocks. So, there are two main types of metamorphism. These are contact metamorphism and regional metamorphism. Now, let's begin with contact metamorphism. When we say contact metamorphism, it is a localized type of metamorphism associated with igneous intrusions. This type of metamorphism usually has a high temperature but slightly lower pressure than regional metamorphism. So dito sa contact metamorphism ay involve ang may maliit na bahagi ng lupa. Makikita natin sa illustration na mayroon tayong iba't ibang layer ng bato. Mayroong, for example, layer A, layer B, and layer C. Then, ano yung nasa gitna na ito? Itong illustration ng bundok na ito. Ito ay ang tinatawag na rising magma. Ang tawag dito ay magma intrusion. So, dahil ang magma ay nakakaangat na at ito ay mainit, it will melt some of the rocks na dinadaanan nito. Itong mga bato na nakapaligid dito, itong layer A, layer B, and layer C. Pero, ano naman yung nire-represent nitong red color? Itong red color sa labas ng orange. Ito yung area na kung saan naiinitan pero hindi siya natutunaw. So dahil sa naiinitan, the presence of the heat will change the chemical composition of the area where is heated. Then Dahil nabago na ang chemical composition nito, hindi na ito yung bato na pinagmulan niya. So, nabago yung form, metamorphism. Then, ito na yung tinatawag natin na metamorphic rock. So, that was the contact metamorphism. Now, let's go to the regional metamorphism. As the word imply, regional, meaning mas malaking bahagi ng crust or slab of rocks yung involved dito. So dito sa illustration natin, mayroong dalawang continental crust na going toward each other. Itong nire-represent ng dalawang arrow na ito. So, ano kaya ang essence niya dahil they go toward each other? So, nagkakaroon ng pressure at ng force. So, dahil available ang pressure, ikukumpak nito ang mga bato para ito ay magiging dense. That's one. Second, there is also a presence of hot area. Possibly, ito ay malapit sa area na dinadaluyan ng magma. Therefore, yung init ay natatransfer papunta sa area na may magma. Papunta sa area na ito. Itong nasa gitna ng dalawang arrow na magkasalubong. Whereas, may mga bato. Posibleng igneous rock, sedimentary, and will undergo metamorphism. So, that was regional metamorphism. Now, here we are at the causes of metamorphism. The number one cause is heat. So, heat provides energy for chemical reactions to proceed, resulting in new minerals to form from original minerals in the source rock. Heat provides the energy that enables individual ions in the rock to mobilize and migrate between other ions, recrystallizing and forming into new minerals. So, heat involved in metamorphism comes from two main sources. Number one, heat transfer during contact metamorphism from magma or igneous intrusions. Number two, progressive temperature increase associated with geothermal gradient as rocks are transported to greater depths below the Earth's surface. So, as the temperature increases, the rate of metamorphic reactions also increases. Then, temperature also increases with depth due to the geothermal gradient. If the rocks are buried within the earth, the deeper the rock gets, the higher the temperature experiences. So, the heat promotes recrystallization or increase in grain size. Another causes of metamorphism is what we call pressure. So, pressure equals force per unit area. Pressure increases with depth as the weight and thickness of the overlying rocks increases. So, pressure is steadily with depth. So, the things to remember here in pressure is the higher the pressure, the greater the degree of metamorphism. When we say body force, forces are applied equally in all directions, such as gravity and weight. As a result, individual grains are compressed closer and closer together. Then, extreme confining pressures that occur at great depths may even cause ions in the minerals to recrystallize and form new minerals. Another one is the surface force. It operates across a surface and occurs when rocks are compressed or extended along a single plane. That is the push and pull forces. As a result, the rocks are shortened or extended in the direction the pressure is applied. Near the Earth's surface, the colder temperature make rocks brittle and more susceptible to fracturing than folding. Deep below the Earth's surface, higher temperature conditions make the rocks ductile and they flatten and elongate as opposed to breaking along a fracture. The resulting rocks then exhibit intricate folding patterns. Another causes of metamorphism is the chemically active fluids. Chemically active fluids that are present between mineral grains during metamorphism act to facilitate ion movement and the recrystallization of existing and new minerals. So, may kinalaman din ang pagdadagdag ng tubig sa formation ng metamorphic rocks. Katulad ng sa lesson of chemical weathering, nabanggit doon yung pag-enter ng water sa bato at yung water ay may kakayahang mag-react sa mga minerals na nasa isang bato. So, in relation to the process of metamorphism, if a fluid like water is available doon sa area na pwedeng mabuo yung metamorphic rocks, yung tubig ngayon ay papasok doon sa bato. That will undergo metamorphism at mabago nito or mag-react sa mga minerals na nasa loob nito, and there will be change in the form, the chemical composition of the rocks of forming metamorphic rocks. So that was the 3 causes of metamorphism. Now let's proceed to the classifying metamorphic rocks by different types of textures. Texture is used to describe the size, shape, and arrangement of grains within a rock. The different textures of mineral grains within metamorphic rocks are used to infer information about the conditions which form them. So there are 2 main types of metamorphic rocks according to their texture. Rocks that exhibit parallel or subparallel orientation are categorized as foliated, while those do not exhibit orientations are categorized as non-foliated. So, let's begin with foliated rock textures. So, ano yung unique sa mga foliated metamorphic rocks? Yung minerals nila are aligned. Kung makikita natin dito sa mga example, makikita natin dito sa next slide ang example ng mga foliated rocks. Na that the minerals are arranged as they go metamorphose. Kasi ang pressure na naa-apply dito ay unequal or ununiform. In addition, pag nabasag o nag-break itong foliated metamorphic rocks, yung bato, hindi siya yung totally na nababasag. Although nagkakaroon ng layered or fragments. So, ito yung bahagi ng bato na natatanggal sa kanya. So, yun yung isang unique characteristic ng foliated rocks. So, ito yung mga example ng foliated rocks. So, 'di ba? Before metamorphism is kalat-kalat yung pagkaka-arrange ng minerals nila. Then, pag na-apply na yung pressure, nagkakaroon ng alignment yung minerals. So, mapapansin natin dito sa mga example. Number 1 is yung slaty cleavage. Diba, yung mapapansin natin sa mga example is parang naka-align. Pag nabasag yung mga bato na ito is nagkakaroon ng arrangement. Hindi siya totally na yung mabasag talaga na. The second classification is non-foliated metamorphic rocks. Non-foliated rock textures form under two basic conditions: metamorphism of monomineralic rocks and metamorphism in the absence of directed stress. So kung ang foliated rocks ay parallel, ang mga particles o naka-arrange, itong non-foliated naman ay wala. Kasi nga, yung force na na-apply dito ay randomly uniform. When these rocks break, there will be no layers and they will not flake apart into thin layers. So dito, example ng non-foliated rocks, yung marble. Pag nabasag itong marble stone is hindi siya mag-split into a flake layer, kundi parang pag nabasag siya is parang pinong-pino, walang layered na makikita. Last one is the metamorphic grade. Metamorphic grade is a general term for describing the relative temperature and pressure conditions under which metamorphic rocks form. So we have two types of metamorphic grade. The number 1 is the prograde metamorphism. It involves the change of mineral assemblages or paragenesis with increasing temperature and usually pressure conditions. These are solid-state dehydration reactions and involve the loss of voltage such as water or carbon dioxide. So, prograde metamorphism takes place faster and produces more dramatic change because of the presence of water in the rocks. And one thing to remember is that prograde and retrograde metamorphism are not balanced processes. The second one is the retrograde metamorphism. It is the mineralogical adjustment of relatively high-grade metamorphic rocks to temperatures lower than those of their initial metamorphism, in which minerals characteristic of a lower metamorphic grade develop at the expense of minerals formed at a higher metamorphic grade. So, if the temperature and pressure decline, then the rock undergo retrograde metamorphism, as the rock and mineral adjust to the reduced temperature and pressure. As we can see in the illustration, the change in a rock that include metamorphism begin with diagenesis, whereas conversion of a loss into a rock pass through the mineral and textural changes of metamorphism and end of the melting of the rock. Then, prograde metamorphism begins with cold or fluid rock and proceed to hot and dry rocks, while retrograde, beginning with a dry rocks, is slower and does not produce as dramatic a change. And of course, retrograde metamorphism can never take you back to the parent rock. So, that's end my discussion. Thank you so much for watching and listening.